Okay, today we have a MacBook Pro. The description, let's see what it says here. Hmm, not switching on. 1278, not switching on. Let's see what we have. First thing first, remember, whenever you have a machine, whenever you have a machine, it's important that you understand the state of the machine before you carry on. So first thing first, we want to define the state of the machine. Quick one, we can see what's the, if we have any battery communication from here. There's a button here that tells you how much power you have in the battery. So you're just going to press on the button and see if you have anything. Nothing. So from here we can as well quickly connect to the charger and just see what's happening, but then it's not ideal. So what we do is, first thing first, we take out the back screws, give it a quick scan, and then see what you're dealing with, and then we take it up from there. So like I said, first thing first, you need to establish exact. So yeah, it's one thing to say it's a no power, it's a no backlight, it's a this, it's a that. That's a general description. Now for you to work on a device, you need to establish a state to say, okay, where are you, what state is the device in. That is what you need to work with. So this is an A1278. It's a 2012, and the board ID, the board number is 820-00. Sorry, 820-00. I'm stuck on non-touchable. 820-3115. So I keep saying 820-00. These are newer devices. So the board ID, the board number, it's 820-3115. It's a 2012. Uh, so let's give it a quick visual scan, see what. Okay, there is no evident sign of liquid, but there is a funny looking cap. Yeah, there was a bit of corrosion around the ISL. Yeah, there was a bit of corrosion around the ISL, but not too noticeable. So what we want to do now is we want to disconnect the battery and then connect our charger, and then we'll continue from there. Disconnect the battery, and remember, whenever you're working on a device, the first thing you want to do after you take out the back cover, it's you want to disconnect the battery, and the last thing after the machine is put together is, after everything is put together, the last thing is going to be your battery. That's when you're putting the device together. However, depending on the type of device, when you're testing as well, you need power, you need the battery balance is to create a battery balance, especially if you're not using an original Apple charger. So battery is disconnected. First and first is going to connect to our charger and see what we have, and then we'll take it off from there. It's a MagSafe 1. So we connect to the charger, we wait for charger communication, and nothing. Let's try that again. Charger communication, we're trying to establish charger communication through our LED here, but we still don't get anything. So let's see if we have PP3V42. I mean, PPDC in, we can confirm if we have PPDC in, but we can, if we have PP3V42, it also tells us that we have PPDC in, because PP3V42 will not be present if there is no PPDC in. So we want to check if we have our PPDC in. We switch our multimeter to voltage mode, and then we see if we have a black probe to ground, and then we can measure our 3 volt by this inductor, and that is 0 volt, nothing. Okay, now let's see if let's try to see if we have power at all coming into the machine. Let's try by the current sensor resistors. Okay, yes, we do have power coming into the machine. Okay, let's see if we, okay, now the next thing we want to do, let's just check that again. Do we have power coming into the machine? Yes, we have power coming into the machine. So that's a PPDC in. However, we do not have PP3V42. Now, definitely the charger communication, PP3V42 is required. Without PP3V42, you will not have charger communication. And obviously, if you don't have charger communication, the machine is not going to start. And without PP3V42, the machine will neither be able to start from your battery or from a connected charger. So first, let's see if we have a short on the PP3V42 line. And then, yeah, we'll take it. So now let's switch our multimeter to continuity mode, black probe to ground, and then our red probe on our inductor for PP3V42. And yeah, we do have a short on that. Okay, I don't know, just went off now. Okay, that was a short, and then it went. Yeah, we do have a short on our PP3V42. So what we want to do now is we want to take out our logic board and then find out where the short is. So for this we need a T6. I'm just quickly going to take out the screws, and then we find out where our short is on the board. So definitely we have a short on our PP3V42 rail. That is why the PP3V42 voltage, that is why we could not get any voltage on our PP3V42 line. So what I want to do now is I want to take the board out. So now you see that we have established exactly where we are on the logic board. Yes, it's a no power, but then you need to the no power is just a general description. You need to be able to establish what is the state of the board or what is the state of the device. From there, you know what to do. Now we have established that we have a short on our PP3V42. Now, first thing first, that needs to be we need to sort that out, because you cannot have a short on the board and expect the board to start. So we need to sort that out, and then we can now move on. Oh, by the way, just a hint. So for A1278, which is basically 2010, 2011, 2012. Um, so when you have your battery not charging, one of the easy way, one of the very easy way to basically troubleshoot you not charging is to disconnect the battery indicator here, disconnect the cable. Because sometimes when you have a short on the data line, because oftentimes when you have liquid in this section of the board, it basically affects. So the effect will be generated through this cable, which is the battery indicator cable. So it's a battery percentage indicator cable communication. So when you disconnect this cable and then you try again, you should get the machine to charge if you have a short here. I mean, so it's one of so those are 2010, 2011, and 2012. And another thing I'm going to do at a separate video, I'm going to start um, uh, doing specific troubleshooting steps on every machine. Say we will be starting from 2011. So we'll cover 13 inches, 13 inches, 12, 13 inches and 15 inches. And then we move on to 20, that's MacBook Air, MacBook Pros. And then we move on to 2013, the same thing, 14, the same thing, 15, the same thing. So we'll basically cover each line of the year. So 2013, all of the devices and how you troubleshoot them, because it's very helpful if you know the known issues of a particular line. Say for example, 2011 MacBook Air, 13 inches. You are most likely expecting, especially given the year, expecting a failed PCH on that machine. Say for example, if a client comes to you and say, I have an issue with my MacBook Air. Say the screen is faulty, and I also have a faulty battery. You want to make them be aware that you're spending so much money on buying a screen and a battery, but this machine very soon you will be having issue with your PCH. So it's important that you understand some of the common failures of each and every device line. So when you're working on them, you are able to advise your client accordingly. It also helps you to do to better troubleshoot your device. Say for example, the 820-3222, the 820-3222. That's I'm talking about the 888 81398, the 15 inches Retina, 2012, early 2013. So with the issue of U8900, for example, if you are very familiar with the common failures of U8900, and then you have a device that has the symptoms of a failed U8900, it makes troubleshooting narrowed for you. It's easy for you to just go straight to the circuitry that is affected, and then you get the device up and running, and then you spend less time because the, the the issues that are not very apparent, for example, liquid damage, and then you say, okay, yeah, this component is damaged, let's fix that component, or let's replace that component. In a situation where that's not the case, it might get a little bit tricky. So it's also very important that you understand. And as a technician, you need to really understand your devices, understand this device, be very familiar with the designs, the common failures, so that when you are working on these devices, you don't have to waste so much time chasing what you're not supposed to chase. So let's just, yeah, enough of the ranting. So yeah, in future videos, we will be going over devices and their common failures and also the troubleshooting methods. Oh, by the way, this is not, this was basically, this is not a field battery. So they try to apply, let's like a long foot. They have like a long foot attached to the back cover. So this was something they used to hold it in place. So it has nothing to do with the battery. So the body's out. We'll just put the chassis aside, and then we'll find out what is wrong with our PP3P42 circuitry. So now we want to take a general look around to see if there's anything that looks funny. So yeah, we did find in this area, I don't know if you guys can see that. So there's a bit of that capacitor isn't supposed to look that way. This isn't supposed to look that way. So basically, that tells us that there was some kind of liquid in this area. So what we want to do is we want to, and also for A1278 2012s, oftentimes you see this here. When you have a short on your PP3P42, usually there's a cap underneath this foam here, so that it usually commonly fails. So all you just have to do is actually take out the foam and then just get your tweezer, or you can use a hot air if you have one. If you don't have one, you can just take a tweezer and just basically knock off the cap, and then you're good to go. But we're not sure if that's going to be the case. So, but then we will check regardless. So let's see if that is the case. Let's see if the cap underneath the foam was affected, and then we take it from there. Okay, so let's just measure again. So our, we are able to get our PP342 measurements on this inductor here. I'm just going to show you. I'm not sure if you guys can see my machine. By the way, we're hoping to get a different camera angle, because I know most of you will obviously not see what it is that we're doing, since the machine is kind of hidden away. So we will try to get a better camera angle so you guys can see what we're doing. So when I say the inductor, so this inductor here, I'm just gonna show you. So this is the board view for your 820-3115. It's 2012, 81278. Now this is the inductor that I am talking about. So on this inductor, we can get our PP3P42. So this is where we're measuring for short. So I'm just gonna measure that again for you guys to see this inductor. So we will have our black probe to ground, and then our red probe on that inductor, and say, and then our meter is set to continuity mode, and then that's a beep. So that tells us that we have a short. So what we now want to do, it's I made mention of this section here. So we have taken that out. Let's just let's see if this cap here has been affected. So one of the ways we can tell that is by basically removing the cap from the circuitry. So if the cap is damaged, with it removed from the circuitry, we should have basically a functioning circuitry. Now you may wonder what has happened for, I mean, so okay, yeah, this is just going to be like a, in the future we'll have to create separate video for that, but fine. But yeah, so what I can see here, the cap seem to be damaged. So what we're just going to do is we're just going to use our tweezer to knock off the cap. That's it, knock the cap off, and then we want to measure again. Let's measure again to see if we have a short on our PP3P42 line, a black probe to ground in our continuity mode. Let's check that again, and our short is gone. We no longer get a beep, so it means our short is gone. Now, so what has happened is the cap that we knocked off. Now, what is that cap? Let's just basically, now this is the section that I was making references to. So it's the audio section of the machine. So now this cap, what's the cap? It's a cap. Is okay. Let's see. Let's see. Mm, mm, mm. So this. So that's. So we have the resistor. I have this one. Hmm. So what we want to do, we're not exactly seeing. It seems to be like yeah. So this is where this was the problem. So now it's knocked off the board, and then we no longer have a short. So now what we want to do is we want to connect our charger to see if we have charger communication. We hope to have charger communication, and we should also hope to see a fan spin. Okay, we have charger communication and we have a fan spin. So that's it. So we have fan spin and then we have charger communication. So what we just want to establish is we want to see if we have if we have PP bus should be fine, but just to be safe, let's measure for PP bus to be sure that our battery will charge afterwards. And by the way, you don't have to worry about putting the cap back. You are 100% okay not putting the cap back. Okay, yeah. So PP bus voltage is exactly how it should be. We will have a battery charging in the machine. So we just basically want to put it in the shell, just see that you get an Apple logo, and then it gets passed to the guys that will finalize the repair and do all of the ticks required, and then the client can collect their device. We just want to quickly, connect the screen and see if we have Apple logo. Okay, so here we want to see if we have Apple logo. Connect our charger. Wait for it. Okay, and then in a separate video, I'm going to be talking about how you can easily identify an original charger versus a non-original charger. Okay, yeah, that's a good thing. We have it's light. I'm not sure if you guys can see that, but I'm just going to show you guys on the other side. That is Apple logo. So we are loading and we are good to go. Okay, that's going to be the end of our video. The repair is complete. Now it's going to go past on to the guys to assemble, do all of the checks required, and then the client can collect. Thank you guys. See you in the next video.